Pegasus was an early vacuum tube valve computer built by Ferranti, Limited of Great Britain. The Pegasus 1 was first delivered in 1956 and the Pegasus 2 was delivered in 1959. Ferranti sold 26 copies of the Pegasus 1 and 14 copies of the Pegasus 2, making it Ferranti's most popular valve computer. At least 2 Pegasus machines survive, one in the Science Museum, London and one in the Manchester Museum of Science and Industry. The Pegasus in the Science Museum ran its first program in December 1959 and was regularly demonstrated until 2009 when it developed a severe electrical fault. In early 2014, the Science Museum decided to retire it permanently, effectively ending the life of one of the world's oldest working computers. The Pegasus officially held the title of the world's oldest computer until 2012, when the restoration of the Harwell computer was completed at the National Museum of Computing Design. Christopher Strachey of NRDC recommended these design objectives. The necessity for optimum programming, favored by Alan Turing, was to be minimized, because it tended to become a time-wasting intellectual hobby of the programmers. The needs of the programmer were to be a governing factor in selecting the instruction set, and it was to be cheap and reliable. The first objective was only partially met, because both program and the data on which it was to operate had to be in the 56 words of primary storage. It was often necessary to resort to tricks in order to reduce the number of transfers between that store and the drum memory. To what extent the third objective was reached depends on how one views a price of £50,000 for Pegasus 1 without tape drives, line print to a punched card input and output, which required an hour or more of preventative maintenance by a resident engineer every morning, before a programmer or operator was allowed near it. Pegasus had 8 accumulators, 7 of which could also be used as index registers. It was the first computer to allow this dual use. Accumulators 6 and 7 were known as P and Q and were involved in multiply and divide and sum double-length shift instructions. It had 56 words of fast memory stored in nickel delay lines, which was supplemented by a magnetic drum holding 5,120 words. A word was 40 bits, of which 1 bit was for parity checking. 2 19-bit instructions were packed into 1 word and the extra bit, not counting the parity bit, could be used to indicate a breakpoint. Optional stop, to assist in debugging. It had a relatively generous instruction set for a computer of its time, but there was no explicit hardware provision for handling either characters or floating point numbers. The speed of arithmetic operations was about the same as the Elliott 402 computer, which could add in 204 microseconds and multiply in 3,366 microseconds. The Pegasus basic instruction cycle time for add, subtract, move and logical instructions was 128 microseconds. Multiply, divide, justify and shift instructions took a variable time to complete. Transfers to and from magnetic drum were synchronous and had to be optimized where possible. The layout of blocks on the magnetic drum was interleaved to allow some processing between transfers to, from consecutive blocks. Applications. In 1956, the first Pegasus was used to calculate the stresses and strains in the tail plane of the Saunders Roe Senior 53. The results were used to check the manufacturer's figures. The programmer was Anne Robson. Because of the importance of a computer, it was housed in the drawing room, complete with an Adams ceiling, of Ferranti's London office in Portland Place. A Pegasus 1 was installed at Cyber House, Sheffield by Stafford Beer for the use of United Steel. It was the first computer installed for management cybernetics. The Pegasus at Southampton University was used for analysis of ground resonance data for the SARO P-531 helicopter that eventually entered production as the Westland Scout and Westland Wasp. In 1957, a Pegasus computer was used to calculate 7,480 digits of pi, a record at the time. In 1959, Handley Page Limited were advertising for experienced Pegasus programmers to join their aviation design team at Cricklewood, London. People who worked on the Pegasus included Hugh McGregor Ross and Donald B. Gillies. See also List of vacuum tube computers. Berners-Lee, C.M. The 22nd of May 1969. Pegasus, a pioneer in reliability and ease of use. Computer Weekly. 12. Lavington, Simon. June 1980. Early British Computers. Butterworth Heinemann. ISBN 9780932376084. Lavington, Simon. 2000. The Pegasus Story. A History of a Vintage British Computer. London. Science Museum. ISBN 9781900747400. The Industrial Era. 1955 to 1957. The 1962 edition of the Pegasus Programming Manual. 38 megabytes PDF. The Computer Conservation Society, who help maintain the Pegasus installation in the London Science Museum.